Here by popular demand, we're going to go over problem set number 2, look at how we can solve these problems, work them out visually, give some thoughts. So here we are, part 1. You own a little furniture store. Over the past 5 years, data show that you have sold an average of 19 dining room sets per month. At the store, answer the following questions. So your first key here is this statement here. Average of 19 dining rooms per month. So this distribution is going to be a kind of a Poisson distribution, because Poissons deal with occurrences per unit. So accidents per month, customers per hour, sales per month. So the average mean is 19. All right. And to find probabilities, we're going to use the formula. The probability that a Poisson has x occurrences is mu to the x times e to the negative mu over x factorial. So in our problem, we have what's the probability of selling 15 dining room sets in a month? Would this be considered unusual? So we want to know what's the probability that the random variable takes on the value of 15. So what are the chances of getting 15 sales in a month? So you have mu to the x times e to the negative mu over x factorial. And that will tell us the probability of selling 15 in a month. And that's going to equal, so using a calculator, I can work this out, and we have mu to the x times, there we have second function e, we have e to the negative 19 divided by 15, and to find the factorial we go to math, probability, and scroll down to exclamation point, which means factorial, and we get 0.65044 blah 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 blah. So probability is 0.065 or 6.5%. So is this unusual? No, not unusual, because the probability is greater than 0.05 or 5%. Okay, so using this notion of 5%, as usual, unusual, and a dividing line, we'll say no, this is not unusual. Something to be careful about. Just because the number of sales is less than the average doesn't make it unusual. If you think of an average, so if the average age in this class is 25 years old, there are people above 25 and people below 25 years of age. So just being below average doesn't mean you're unusually young. Being over 25 doesn't mean you're unusually old. Okay, so to find an average, there's always going to be values above and below, so the fact that it was less than 19 doesn't make it unusual. Okay, we can determine it by the probability. So let's see what the numbers say. So evidence from the data. So you want to know what's the probability of having 26 sold in a month. So it's a probability that x equals 26, mu to the x, e to the negative mu, x factorial, probability of selling 26 in a month. Look at our fancy calculator. So our calculator will help us with this. So 19 over 26, so that's u to the x times second function e to the x, e to the negative 19 divided by 26 factorial equals 0.024568, blah, blah, blah. So roughly 0.0246 or 2.46%. So if we assume the average is 19, the probability of getting that many is 2.46% or 2.5%. Is this unusual? Yes, this is unusual. This is an unusually high month because the probability is less than 0.05% or 0.05 or 5%. So this is an unusual month. So what does that tell us? Well, given the assumption of 19, getting that many is unusual. So we do not prove anything. We prove nothing. We can't prove that the ad campaign was effective. It may be effective because this is such an unusual month, but this could just be a random unusual month. To ensure maybe that in your mind that the ad campaign is effective, maybe we'd go for another month or two if the number of sales is high, then that might suggest to us that in fact, yeah, the assumption of an average of 19 is not a good one. Maybe an assumption of a higher mean is more appropriate. So there's part one. So part two talks about Erica's Bottled Water Company. They make bottled water. Suppose 20-ounce bottles of Erica's water are filled by an automatic machine. The contents of the bottles are normally distributed with mean 20 ounces, standard deviation 0.31 ounces. So here we know this is a normal distribution. You know this because it says the bottles are normally distributed. If something is a normal distribution, you will only know because it says normally distributed. That's the only thing that will tell you it's normally distributed. It will never say normally distributive if it's not a normal distribution. So this is kind of the dead giveaway. Bottles are normally distributed. So we have a normal distribution. And the mean is 20. Standard deviation is 0.31. So what are we trying to find? Part A, you collect rare Erica's bottled water. You get a bottle that's filled with 20.89 ounces. What's the probability of getting a bottle that's filled with at least that much? Is that rare? So we want to know what's the probability of getting a bottle that's more than 20.89 ounces. So the probability of that is the probability of getting a z-score greater than value minus mean divided by standard deviation. That's the z-score. The value minus the mean divided by standard deviation. So what's the probability that so we're trying to find the probability that the z-score is greater than 2.87, roughly. So in our table, we can find the probability of being less than a particular z-score. So the probability of being greater than is simply 1 minus the probability of being less than that z-score. And if we look at our z-table, z will come down here to 2.8 over 2.7. So that represents 2.87, and we see 0.9979. So we'll take 1 minus 0.9979, and that equals 0.0021, or 0.21%. Is this a rarity? Oh yes. Probability is certainly less than 0.05, less than 5%. So we would say this particular bottle would be a rare one. Any bottle filled with at least that much, at least 20.89 ounces, would be considered a rare bottle. That's part A.